Hello, everybody. This is Quilkin, deconstructing the game server monolith with proxies. My name is Mark Mandel. I am a developer advocate at Google Cloud. Thanks so much for joining me today. So, today we're going to talk a bit more about dedicated game servers for multiplayer games. Again, common pattern for high paced multiplayer games, thinking things like Rocket League, games like that. Uh, Usually, your central authority for everything that's happening inside a game, your full simulation, all your players connect to it, and it tells everyone that everything is happening inside your game. But there are some challenges with dedicated game servers. They can be a single point of failures. They're just one big binary hosted on a machine. So if somehow they go down, that's a problem. They can tend to be a big monolith of code as well. On top of that, the IP import very often of the dedicated game server is exposed, which means that they're a very easy target for attack. So there's some fun challenges that exist with dedicated game servers and especially running them at scale. On top of that, the network communication protocol patterns that we see for games are interesting. Usually, right, exclusively UDP based for a variety of very good reasons. There's a lot of very common. There's a wide variety of standards, or even not really standards, for this type of communications. There's some open libraries. Some use some reliable forms of UDP or reliable forms of that. Security encryption can vary greatly. And packet and serialization can be all kinds of different types. It's a bit of a wild west, which makes it a really hard thing to standardize on. So, what can we do to help sort of mitigate some of those challenges and maybe possibly create some opportunities as well? So, if we look at wider tech, so like mobile and web apps, we see that proxies are actually usually a great solution for some of these kinds of problems. So, if in a magical world we had some kind of UDP proxy, we were able to provide redundant points of entry. We have opportunities for breaking apart the monolith. We could also potentially provide some standard tooling and maybe be able to implement some standards or help guide people towards certain standards and best practices, and just generally making the whole thing a bit harder to take down and less of a target for attack. So, strangely enough, I'm here today to talk to you about an open source, non transparent UDP proxy specifically built for gaming. Now, I'll be upfront with you, it's still very new, it's alpha, but I'm very pleased to announce that we have built this in collaboration with Embark Studios, a bunch of fantastic people that have helped us shape this in a wonderful way. And we'd love to have you come and play with it. But let me tell you about it, and we can get stuck in, and you can learn if it's a good fit for your needs. So, Quilkin proxies, it was built such that it can be used both client side and server side. Why is that important? This is useful because that means that we are able to specify complementary types of filters, some of which we'll look at, like things like compression, things like that need to be implemented on one side and the other. What we want to be able to do is do that in a way such that you don't have to change your game server or your game client as your traffic all the way flows through. And as an important note, we've set it up so it can be integrated as a binary or as a library. We have a standalone library that you can use as well as a Docker container, but the whole thing's written in Rust with FFI bindings if you want to use it both if you want to use it as a library or if you want to extend it. So very quickly, I'm going to take you through some sample use cases and integration patterns so you can get stuck into that and you can get some ideas of how it could potentially be used inside your game server system. So the easiest way to integrate Quilkin is just as a sidecar, running right next to your game server. We'll see a demo of this in a minute. This is the easiest integration, basically the safest. The benefits here, suddenly you get access to like metrics and tracing on your packets. You can start to see the information that's coming through. You may not necessarily have got that before, and you can also do all that work outside of the game loop for your dedicated game server. There's some filter applicability here as well. You could put in place rate limiting, for example. Basically, anything you can do just right next to that game server is available for you without you having to change too much of your orchestration layer that sits for your dedicated game servers. Now, we can take that one step further. We can add a client-side proxy, as we were talking about before, with complementary filters. We can do things like compression, which I'll show you a demo of in a minute. Eventually, we want to be able to do encryption as well. We haven't got there yet. We're looking at several different options. But anything where you've got that complementary traffic translation on both sides, you can suddenly do now with these proxies in place without you having to change your dedicated game server or your client. Now, we can take this even one step further. We could have a pool of proxies, which can be dynamically controlled by the system that is orchestrating your game servers through an API service that's called XDS. If anyone's familiar with it, it's a standard for proxies. Um, these could be either right next to your game servers, they could be at the edge. There's a few different options about how you could do that. And then you could tell your game clients about maybe some or all of your proxies. This is super nice because it's much easier, sorry, it's much harder to take down because there are multiple proxies. And you can therefore hide the information about what your dedicated game servers are doing there. To take that even one step further, we're able to provide you with some common functionality inside Quilkin that's available right now for doing sort of routing and access control. So we're able to put filters in place so that you're able to add a security token to your packets as they come out. Quilkin proxy on the server side would be able to then validate and authenticate and then route to the appropriate dedicated game server based on that token. This could also then mean that if a player doesn't have a valid token, they get kicked off. Or if you realize that a certain player is doing something that they're not supposed to do or possibly malicious, you're able to then quickly drop their token from the entire system, and then suddenly they no longer have access. This can be super nice because then you can get it down to the player level, not necessarily just down to the IP level, which can be a little bit useful. Okay, I want to show you a little bit of this in action. I think we'll have a really cool demo, so let's get into that. So here what we have is an already set up Agones cluster with some Sonotic dedicated game servers. Sonotic's a fast-paced first-person shooter. If you watched the previous talk about Agones, you would have seen it in action there. So if I look at the game servers that we have available, you'll see we have them set up a little bit specially here, just from the name. So in this particular instance, what we have is Sonotic set up with Quilkin as a sidecar. That will mean that when I connect with my client, the traffic is going to go through Quilkin and then into the Sonotic dedicated game server and then come back out again, which is kind of neat. So there's another one there. We're going to talk about that in just a second. So if you're familiar with Agones, usually we would do allocation. I'm going to be a little lazy here and skip that here. But I'm just going to connect a Sonotic client to this particular instance here that has Quilkin running as a sidecar. 236.19.213.7405. So again, if you watched the talk I did previously about Agones, or you've seen any of my other talks, this will look pretty familiar to you. Nothing will look probably any different, which is kind of the point. This is going to work and react basically like I was connecting directly to the game server. I'm getting, fragged straight away, and I'm able to play this game like I would do normally. Nothing really that strange is happening. I would like to get, let me take out one of these people. All right, cool, fantastic. I'm just going to shut that down right now. But what this does give us, which it wouldn't otherwise have been able to do so, is if we pop over here, and I'm just going to refresh Grafana here, we get access suddenly to a whole bunch of data. I've been running a few sessions of this, but we can start to see things like, what are my network traffic rates? How many instances of Quilkin do I have? How much data am I transmitting and receiving? I didn't have to make any changes to my game server or my client. I could just put Quilkin in the middle, and suddenly I have access to a huge amount of data that I wouldn't have previously. Quilkin has a whole bunch of metrics. We talked a little bit about that before, but this just gives you a taste of what's available. But we can take this a little bit further, which I think is super, super cool. So let's come back over to my console. We have this Sonotic sidecar compress here as well. We have this set up so that this sidecar that is running next to Sonotic expects compressed UDP packets in the snappy format to be coming in. So how do we compress it on the client side? We can run a client proxy on the client side as well. So I'm going to grab this one here. So what I'm going to do is edit a client compress file I have here. So let's go client compress YAML. This is just a configuration of Quilkin. Again, I could do this programmatically as well. Could be a number of ways I could set this up, but I'm just going to use YAML. It's easy. And I'm going to copy in the IP import that we had here previously. Okay, so this is actually going to compress the traffic from locally, make it so that when it goes up to the place it's supposed to go, which is this game server, it's able to understand it because it's thinking and decompress that. So let's run Quilkin locally here on port 77000. It's loaded that up. It's ready to go. So let's pop over to here. We'll fire up Snodic again. Quilkin's ready. So instead of connecting directly to the game server up in the internets, let's actually connect to 0.1 port 7000. So that's going to connect to my local proxy. It's going to compress that UDP traffic, send that up to the dedicated game server that's running on Agones that has a sidecar that's expecting compressed traffic. And it does a half decent job of compressing. We'll actually see the data. You'll sometimes it does a better job than others. But again, nothing has changed, right? Like the same experience as what we were seeing before is exactly the same as what we're seeing now. But suddenly we're able to manipulate that data without having to make any changes to our game server or client. If we come back over to our Grafana dashboard, as we saw here, we can see we have some data going backwards and forwards. It looks a little better. That's nice. Generally what we want to see when we do compression. Here it goes up. Like I said, sometimes it's a better job than others. Totally fine. But we're able to see the data, see everything that's going in. We can actually dig into some of the compression metrics as well. So this just scratches the surface of what's possible with Quilkin, but hopefully it gives you some ideas. All right, that should give you a bit of a sense of what's possible with Quilkin. Now, like I said before, the project is alpha. It's still very new. It's only been out for a few months. But here's some of the items that I'm particularly excited about on the roadmap. As you can see, there's quite a number of them. We're looking into how we can do distributed tracing, potentially with OpenTelemetry, so that you can see down at the player level what's happening with their packet data. We also want to implement a system for rules and actions so that if someone either malicious or accidentally does something within your system that doesn't really adhere to what you're expecting, you're able to notify a system to let them know that this is happening and they can react accordingly. A whole bunch of new filters. We've got all kinds of ideas on our GitHub issue list. Encryption's a big topic. What best practices can we put in place for security around your communication protocols? Asynchronous filtering, say for if you want to do some sort of batch processing or querying or deep inspection of your packets, I think there's really interesting opportunities there as well. Definitely a whole bunch of more tools around development and testing. We want this to be a platform that you can extend because we realize that not all protocols are standardized and you may have your own. There's some things you might want to be able to do just for yourself. So we want to make that easy and lightweight for you as well. Also, sometimes Rust is just not appropriate, so we want to make sure we have some lightweight integrations with regular standard game engines as well as opinionated control planes for Agones, Google Cloud Game Servers, and OpenMatch. Oh my god, yeah, there's a whole bunch of stuff we want to work on. It's all super exciting, and if it's interesting to you at all, please come and check out our issue list on our GitHub. If you want to find that, you can find it here at github.com/Google4Games/Quilkin. You can also find details for our Discord server, as well as our mailing list and our community meetings. We would definitely love to have you come be involved with this project. Not only do we have an adorable mascot, but we also have a bunch of very talented people who would love to come meet you and talk about UDP and game servers. All right. Thank you very much.